Next up, we have student researchers from Springfield, New Jersey, Team 2. It's a Mission 11 flight experiment.
Good afternoon. We are 7th graders from Florence M. Gardenier Middle School. Our experiment is which types of lettuce seeds grow best in microgravity. We are from Springfield, New Jersey, located about 22 miles west of New York City. Our middle school has about 508 students, grades 6 through grades 8. Our experiment deals with 4 different types of lettuce seeds. We would like to know which of the 4 seeds that we experimented with germinates the fastest. Will microgravity affect the rate at which the seeds start to grow? Our team of investigators includes 7th grader Maxwell Levy, 7th grader Ian McClear, and 7th grader Elijah Acosta, who could not be here today. We had a 4th investigator, Bertie Vias, but he and his family moved to Pennsylvania. Our teacher, Mrs. Allison Gillen, could not be here today.
We began this project by wondering what would happen to lettuce seeds in microgravity. We found that several varieties of lettuce seed and wondered if they would all germinate at the same rate. We tested the seeds in our classroom and found that indeed all the seeds grow at slightly different rates.
The 4 types of seeds we work with are listed on the slide. They are Grand Rapids seeds, black-seeded Simpson seeds, iceberg lettuce seeds, and loose-leaf blend lettuce seeds. Based on our work, we found the black-seeded Simpson seeds grew the fastest.
Based on our work in the classroom, we would like to know if the seeds will grow at different rates in microgravity. We have chosen to use a Type 3 FME lab. In the first chamber, we will put the seeds. Each seed will be embedded on a piece of gauze and stacked so we can identify the seeds. The middle chamber has water to start the germination process. The final chamber contains the fixative, which will stop the seed growth at the end of the experiment.
We found that the 4 varieties of lettuce seeds did not grow at the same rate on Earth. Our data shows the black-seeded Simpson lettuce grew the fastest with roots lengths of 2.2 centimeters in the half-a-week time period. The second lettuce seeds, iceberg lettuce, grew about 2.2 centimeters as well. The other 2 lettuce seeds we experimented with, Grand Rapids and loose-leaf blend roots, grew about 1 centimeter in the time period.
We feel that this experiment is a very important experiment to do in space because currently red romaine lettuce is the only lettuce grown on the space station, and we would like to discover more types of lettuce will be able to grow in space too. Also, we think that the experiment will be important to do in space because we would like to find out if the variety of lettuce seeds vary in germination time. There is currently a greenhouse on the International Space Station. The greenhouse has many different types of plants growing in it, including red romaine lettuce. We hope that our experiment shows that more types of lettuce can grow in microgravity.
At U14 days, which is 14 days before the experiment will be sent home, the astronauts will release clamp A to release the water into the seed chamber. This will start the germination process. At U5 days, which is 5 days before the experiment is sent home, the astronauts will unclamp clamp B to release the fixative. This will stop the growth of the seeds. Once the lab is returned to us, we will compare the growth of the seeds that were on the ISS to those on Earth. We would like to thank Dr. William Palmer, a lettuce expert from University of California, Davis. He was very helpful on his advice on growing seeds, lettuce, information, and encouragement with our project. We'd also like to thank our teacher facilitator, Mrs. Allison Gillen, and our other teacher facilitator, Mr. Greg Sammies over there. And we'd also like to thank our parents for all their help with the encouragement with the project. Thank you.
Do we have any questions for this team?
My name is Molly from Springfield, New Jersey. And why did you choose those 4 types of lettuce instead of any other types of lettuce?
We chose these 4 types of lettuce because we researched different types of lettuce and we found that these were the best ones that could grow. And also we found that since they only grow red romaine lettuce on the International Space Station, we wanted to find out if these 4 types of lettuce can also grow to improve the growth of lettuce seeds in general in space.
Thank you.
Hello, Angelica from Vista. I noticed that in your preliminary experiments you did 2-week growth of the lettuce, but for the space flight experiment, it looks like you are asking them to unclap at U14 and then to freeze them, well, to add the formalin at day 5. So that's just 9 days. Why the difference in the amount of time to see growth?
The difference in time is because in our classroom, we were able to have enough time to do it, and all our seeds were helped with us. And on the ISS, there may be other groups doing the same things, and they may have to go through and not have enough days to help do ours.
Jeff Goldstein, Center Director for the National Center for Earth and Space Science Education. So for the 4 different varieties of lettuce seeds, what is the average germination time for each of those species?
The average germination time is, what was it? 9 days, I think.
9 days?
Yes.
And is it different from one species to the next?
I think so, yes.
Do you happen to know what the differences are for the different species in terms of germination time?
We don't know that specifically yet, but that's what we would like to know.
Okay, now you're a Mission 11 experiment, right? So
Yes.
you're getting ready to onboard. Now, if you're unclamping at U-14 and hydrating the seeds, and the germination time is 9 days, and you're then introducing the formalin with the second clamp at U-5, 9 days later, they won't germinate. So the experiment will fail.
Okay.
So what I'm suggesting, in the interest of maximizing this experiment, you need to unclamp clamp 2 at U-2.
Okay.
Do you see what I'm saying here?
Yeah, I
Right?
see.
U-2 is
Okay.
the last crew interaction opportunity. That'll give you 11 days, which means that some of those seeds have the ability to germinate and grow before you introduce the formalin.
Right.
It's critically important that you guys go back and you look very, very carefully at the germination rates for each of those species to make sure that those species will indeed work with the crew interaction days that we are required to use, okay? It's the difference between success or failure of this experiment.
Okay. Thank you.
Hi, I'm Dermot from Springfield, New Jersey. I have more of a comment than a question. The second group that presented today was using yeast, and one of their concerns was the buildup of gas when you mix the yeast to grow the yeast. Then one of the things they commented on was making alcohol so they can use that for a disinfectant. When you make alcohol, the gas you give off is carbon dioxide.
Right.
You showed a beautiful picture of the greenhouse, and I don't know if you guys all know this, but plants need carbon dioxide to grow. So the problem they have could be a benefit to you guys. They could be giving off carbon dioxide, figuring out what to do with it. The plants could use that to grow and then take it away from the problem of building up carbon dioxide. So you guys should talk, and maybe both of your experiments would get even better if you got together and put them together, use their carbon dioxide, which gets rid of it for them, and you can use it to help grow your plants.
Okay.
What do you think?
Pretty good. Yeah. Thank you.
Hi, I'm Jade from Vista. I noticed in your proposal you were going to stack the seeds in the tube, in the FME tube, but in your prelim testing you didn't. Will that affect the stacking the seeds? Will that affect the growth?
We don't think so, because that's what we just prepared them. We put the seeds and we put 4 seeds. We had gauze that we put them in. We put 4 different types of seeds in gauze, and after our research, we don't think it will affect that. Thank you.
Thank you, guys.
You're welcome.